Hi everyone, this is Dr. Nak. Today we're going to learn about circles. Now, before we start, for the prep work, please go over completing the squared for this section. In this section, we're going to learn how to write an equation of a circle in standard form and write the general form of an equation of a circle. We all know what the circle is, but let's just read it mathematically. So here's the definition of a circle. It says a circle is the set of all points in a plane that are equal distance from a fixed point called the center. The fixed distance from any point on the circle to the center is called the radius. So here it is. This is the center of the circle, and this length here is called the radius. So if I go from the center to above, center to the left, or center to on this side, any point on the circle, they have all the equal distance of length r. Now, to write the equation of the circle, we have two different forms. One of them is called the standard form, and the other one is called the general form. So let's first go with the standard form of an equation of a circle. It says, given the circle centered at h, k with the radius r, the standard form of an equation of the circle is given by x minus h squared plus y minus k squared equals r squared, where r is strictly greater than 0. And do you see why it's strictly greater than 0 and not greater or equal to? Because think about it. If it's equal to 0, right, can we even draw a circle? No, we're just going to get a point on the plane. So that's the reason why your r must be strictly greater than 0. Now let's go over the general form of an equation of a circle. It says an equation of a circle written in the form x squared plus y squared plus ax plus by plus c equals to 0 is called the general form of an equation of a circle. Suppose you're given the standard form of the equation of the circle. It's not too bad to get to general form because all you have to do is you basically multiply everything out, right? And then bring everybody on the left-hand side, and then you're going to set the right-hand side equal to 0. Then you got yourself a general form. So standard form to general, it's not too bad. Now, going the other way around, we're going to have to work it. So going from the general form to standard form, that's when you have to complete the squared. That's the reason why I want you to review the completing the square section. I know that I just give you boom, here's the formula, but since we're in pre-calc, let's find out how this formula came along. Now, previous section, do you all remember we learned about the distance formula? The distance between 2 points, x1, y1, and x2, y2 is given by d equals square root of x2 minus x1 squared plus y2 minus y1 squared. So which means that the distance between 2 points, let's just say h, k, and some x value and a y value is given by, so just pretend that this is your x1, y1, and this is your x2, y2. And if I follow the formula, instead of d, let me just call it r. So that's going to be the square root of x minus h squared, and then plus y minus k squared, all inside the square root. Now, let's try to get rid of that square root by raising both sides by power of 2 to get r squared equals x minus h squared, and then plus y minus k squared. Boom. Now, isn't that precisely the equation of the circle in standard form? So now you know where it came from. All right, now let's start doing some examples. Example 1, write an equation of a circle in standard form and graph the circle. So let's first look at this example here. Center is given by -5, -2, and radius is square root of 21. So let's first write down the formula. So here, standard form of an equation of the line, it says x minus h squared plus y minus k squared equals r squared. Okay, so now let's just jot down what we're given. So the center, so this -5 is going to play the role of your h, and then your k becomes your -2, and the radius of square root of 21, this is precisely your r. So now all you have to do is just plug and chug. So let's go. So this means we're going to have x minus -5 squared plus y minus -2 squared equals square root of 21 squared. So then let's just clean up a little bit. Then we're going to get x plus 5 squared plus y plus 2 squared equals 21. So that's the equation of the circle in standard form. Now let's graph this out. The center is -5 comma -2. So when x is -5, where in the heck is that? 1, 2, 3, 4, 5. So that's -5. And the y value is going to be -2. So our center is going to be here. Now the radius is square root of 21. Now that is going to give you some decimal value. So I think square root of 21 is approximately 4.6-ish. Okay, so which means that from the center, you're going to have to go approximately 4.6 units above, below, left, and right. Okay, so let's do it. So 4.6 above will be 1, 2, 3, 4.6. Maybe it's right here. And then let's go downward. 1, 2, 3, 4.6. Okay, to the right. 1, 2, 3, 4.6. So notice that we're not going to have the y-intercept. Remember what the y-intercept is, right? It's where the graph is going to touch or cross the y-axis. Anyway, so let's keep going. To the left, 1, 2, 3, 4, and 4.6. Here we go. Now all you have to do is connect those dots and try to draw a pretty circle. But you know my skills when it comes to graphing, so just please bear with me. Oh my gosh. That's not too bad. Okay, that almost looks like an egg, but okay, so pretend that that's a perfect circle. The next example says the center is 3, 1, and another point on the circle is 6, 5. So here, since we're given the center, we already know the value of h and the value of k are going to be. So now let's just write down the standard form of the equation of the circle. So that's x minus h squared plus y minus k squared equals r squared. Okay, so let's just fill in the blank. So you're going to have x minus 3 squared plus y minus 1 squared equals r squared. So here, we don't have the value of r. So now what we need to do is, given information, we're going to have to find the value of r. So r equals to what? Now, do you all remember this from last section? If the point 6, 5 is on the circle, that's on the graph, then it must satisfy the equation. Do you remember that one? So that's the information that we're going to use to find r. So let's do it. So here, let's just say when x is 6 and y is 5, then we're going to plug those values into the equation that we just wrote. So then here, what we're going to get is 6 minus 3 squared plus 5 minus 1 squared equals r squared. So here we're going to have a 3 squared plus 4 squared equals r squared, which is 9 plus 16 equals to r squared, which means that 25 equals r squared. Now, taking the square root on both sides, we're going to get r equals plus or minus square root of 5, but we're talking about the radius, so we're trying to pick up just the positive portion of it. So our r is going to be 5. So let me just box this because I need r squared to fill in the blank here. All right, so then I think we're good to go. So therefore, our equation of the circle in standard form is going to be x minus 3 squared plus y minus 1 squared equals to 25. Now let's graph this out. So let's first plot the center, which is x is 3, and then y is 1. So the center is here. Now from this point, what we're going to have to do is we're going to have to go 5 units up, down, left, and right. Okay, so let's do it. So here, let's go upward. 1, 2, 3, 4, 5. Make the dot. 1, 2, 3, 4, 5. Make the dot. 2, 3, 4, 5. And then 1, 2, 3, 4, and a 5. All right, looking good. And we're going to have to connect all those dots to make a circle. Okay, I can do this. I can do this. Oh gosh. Like 100% concentration here. Oh, look at that. That's not bad. All right, so that's the graph of the circle. And where is 6, 5? Because 6, 5 has to be on the graph, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Oh, I'm close. So let me just put a big old fat dot here to indicate that, yes, 6, 5 must lie on the graph. Now let's do this example. We're given that the center is -2, -5, and circle is tangent to the x-axis. If you're not familiar with what the tangent line is, it's just this. So here's the circle, and I plot a point here. Now, this straight line here that just touches the point in question and is almost in a way parallel to the graph at that point. So let's just see, if I pick a point here, the tangent line to that point is the line, straight line, that's going to touch that point. So let's start. So first, let's write down the formula or the equation of the circle in standard form. So this is x minus h squared plus y minus k squared equals r squared. So here we're already given the h and the k, so let's just plug those in to get x minus -2 squared plus y minus -4 squared equals r squared. Clean it up. We're going to get x plus 2 squared plus y plus 4 squared equals r squared. So again, for this problem, the question is, what is the value of our r? We only know the center and the fact that the circle is tangent to the x-axis. So in order to find r, let's just draw this out. First, jot down the center, which is -2, comma -4. 1, 2, 3, -4. So the center is going to be here. So now, can you compute what the radius is going to be? Think about it a little bit. And your graph has to be tangent to the x-axis. I'm not sure if you can see this or not, but I just drew the tangent line here. So the only way this problem is going to make sense is that, remember, this circle has to be tangent to the x-axis, which means that no matter what, the circle must touch this point here. So now can we discover what the radius is, right? I think we're good to go, no? So starting from here, we're going to go 1, 2, 3, 4. So here we know that radius is going to be 4. So let me write that out. So here we're going to have to go radius must be 4. Okay, now since we're going to have to graph this anyways, so let's just finish this. Okay, so then I'm going to go 4 units downward, 2, 3, 4, and 4 units to the right, 4 units to the left. So now all we have to do is connect those dots and try to make a circle out of it. Oh gosh, that's not too bad. Okay, so now let's finish the problem. We know now that the radius is going to be 4, so therefore our equation of the circle in standard form is going to be x plus 2 squared plus y plus 4 squared equals 4 squared. So, which means that we're going to get x plus 2 squared plus y plus 4 squared equals 16. Let's do another one. Remember, practice makes perfect. All right, so the next one says, write an equation that represents the set of points that are 9 units from -4, -16. Okay, so let's just kind of give it a rough sketch to see what the question is asking us. So it says, write an equation that represents a set of points that are 9 units from -4, -16, right? So let's just pretend this is -4, this is -16. So here is that point. Now, we want to find all set of points that are 9 units from that. So what we need to do is from here, you're going to have to go 9 units above, and then 9 to the left, 9 to the right, 9 to the bottom, right? And then do you see that this circle here consists of all the points that are 9 units from -4, -16, right? So here, it's not too bad because now if you draw it out, can you tell what the radius is? Radius is going to be 9. Okay, so then we can bust out the standard form. So we got x minus h squared plus y minus k squared equals r squared. So then -4 is going to be our h, -16 is going to be our k, and we just found out that our r is going to be 9. Okay, so let's plug and chug. So then here you're going to have a x minus -4 squared plus y minus -16 squared equals 9 squared. Okay, so then here we're going to have x plus 4 squared plus y plus 16 squared equals 81. So that is the equation of the circle. My apologies for this graphing grid is super tiny, but I have to go 9 units from -16. That's the reason why I kind of have to shrink it a little bit. But anyways, let's first jot down the center, which is -4, -16. Oh gosh, my eyes hurt by doing this. Hold on, is it here? Okay, now from here, we're going to have to go 9 units up and down. So let's go. Let's first go upward. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Downward. 1, 2, 3, 4, 5, 6, 7, gosh, 8, and then 9. Okay, now to the left. Yikes. Okay, so now all you got to do is draw the circle by using those 4 points. So let's go. Oh my gosh. I can't do this. Okay, that was not the best, but please pretend that's a circle. Our next topic is general form of an equation of a circle. Now, at the very beginning, do you remember we talked about there are 2 different forms to write an equation of the circle? One of them was the standard form. Now we're about to learn about the general form. It says an equation of a circle written in the form x squared plus y squared plus ax plus by plus c equals to 0 is called the general form of an equation of a circle. Now, those a, b, and c, they're nothing but real numbers. When we write the equation of a circle in general form, sometimes something funky might happen, which means not all general form is going to produce a circle. For an example, if you get r equals to 0, or r means radius is 0 or radius is negative, when that happens, we call that degenerate case. So when r equals to 0, right, we talked about this earlier. So when the radius is 0, can we get a circle? No. So when r equals to 0, radius is 0, what we're going to get is just a point on the plane. Definitely not a circle. Now, can we have a negative radius? I don't think so. So in this case, if r is a negative number, which implies that the circle does not exist. D-N-E means does not exist. And if we get one of these cases, we say that those are degenerate case. Before we do a concrete example, let's take a look at this. So suppose, right, we're given x minus 1 squared plus y plus 3 squared equals to 16, let's just say. Can you tell that that's an equation of the circle? So this is a circle. And with the center is at 1 comma negative 3, and the radius is going to be 4. Now, let me multiply this out and see what we get. So here, x minus 1 squared means x minus 1, and then multiply by another x minus 1. So be careful right here. This does not equal to x squared minus 1 squared. Okay, so be careful. We're going to have to FOIL it. And then here, your y plus 3 squared can be written as y plus 3 equals 16. So now we're about to FOIL this. So then you're going to get x squared minus 1x, and then you have another minus 1x, so that's going to give us minus 2x. And if I multiply the last term, you're going to get plus 1. And then for the y, you're going to do the same thing. You're going to go y squared, that's multiplying by the first term. The next term is going to be 3y plus another 3y. So that's going to give us plus 6y. And then if you multiply the last terms together, you're going to get plus 9. And that's all going to equal to 16. Now let's simplify this a little bit, and I'm going to rearrange the ordering here. So you're going to have x squared, and then plus y squared, and then you got minus 2x plus 6y, and then I can combine those constant terms. I have a 1 plus 9, so that's going to give us plus 10 equals to 16. Now let me subtract 16 from both sides. So here what we're going to do is I'm going to minus 16 and minus 16. So then we're going to get x squared plus y squared minus 2x plus 6y minus 6 equals to 0. Now look at it. Isn't that in a standard form? Because the standard form must look like x squared plus y squared plus ax plus by plus c equals to 0. Since we derived that general form from the standard form, when you graph this out, we should get a circle of center at 1 comma negative 3 and a radius of 4. They look completely different, but they will produce the same graph. So going from the standard equation to general equation, it's not too bad because all I had to do is multiply everything out and combine the like terms and bring everybody on the left-hand side and set the right-hand side equal to 0. But what if we're given this, which is the general form? How are we going to get back to the standard form? So that's our next topic. So the answer is this. You're going to have to complete the square. So let's start doing some examples. Example 2, write the equation of the circle in standard form. If it's a circle, determine the center and a radius. So first example, we're given x squared plus y squared plus 10x minus 6y plus 25 equals 0. So this is what I usually do. I separate x's and y's from each other. So here, let me just rewrite it like this. So we got x squared minus 10x. Leave a little room because we're about to complete the squared. And then you're going to have a plus y squared minus 6y. Leave a little room and then toss that 25. Move the 25 on the right-hand side by subtracting 25. So on this side, you're just going to get a negative 25. Okay, so let's complete the square. So how do you do it? Is this. You divide the middle number by 2, including its sign. So here you're going to have a negative 5. Now what goes in here is you're going to have to add in negative 5 squared, which is plus 25. Now look at the equation, right? Do you see that our equation, I just added 25 to this equation, so it does not equal to the original equation. So we need to balance this out. So right now, think of it as given equation. This guy is 25 units heavier. So how do I balance it out? Yep, you're going to have to subtract by 25. So which means that I'm just going to be adding in 0 to the given equation, so which does not change the original equation. All right, and then let's do the same thing for the y. So let's complete the square on the y by dividing a middle number by 2. Then you're going to have a minus 3. And what goes in here is you add in the negative 3 squared, which is plus 9. But if you're going to add in the 9, you better subtract by 9 to balance everything out. Now, what the heck does this all mean? So if you have practiced how to complete the square, you should know this already. But the first 3 terms is going to become the perfect squares, which means that you should be able to write this as x here and then something completely squared. Now, what goes in here after x is the number negative 5. So that's what goes in. So basically, I'm inserting this number right after x. All right, and then we still got minus 25, so let me just leave that. And then next one, again, the first 3 terms are going to become the perfect squared. So here, what we're going to get is just drop down this plus sign. And then here, that's a plus sign. And then you're going to have a y something something whole quantity squared. So again, what goes in there is this number. So in this case, we get minus 3. And then don't forget to write minus 9. And this whole thing is going to equal to negative 25. Now all you have to do is this. Move those constant. We have a negative 25 and negative 9 on the right hand side by adding 25 and adding 9. So here, then let me just write every step out. So you're going to have x minus 5 squared. And then plus y minus 3 squared equals negative 25. Now, I'm going to add 25 to both sides to get rid of this minus 25. So here you're going to have plus 25. And doing the same thing for minus 9. So I'm going to bring this minus 9 on the right-hand side by adding it. So here you're going to get plus 9. So let's rewrite. So therefore, we got a x minus 5 squared plus y minus 3 squared equals 9. So we got ourselves an equation of the circle. So let me just write, this is circle, centered at 5, 3. And the radius, be careful here. So the 9 is the radius squared quantity. So here your radius is going to be 3. Okay, so now let's take a look at this example like this. We got x squared plus y squared minus 10x minus 22y plus 155 equals 0. So you know what? Why don't you try this problem on your own? So, please pause the video and go for it. Just try it out. All right, so how did you all do? Were you able to figure it out? So let's go over it. Okay, so first what I'm going to do is doing the same thing. I'm just going to combine all the x's together and the y's together. So I'm going to have a plus y squared minus 22y. And then I'm going to bring that 155 on the right-hand side by subtracting 155 from both sides. That says negative 155. Okay, so then let's complete the square. So first, what we're going to do is divide this number by 2. So we're going to have a negative 5. So what we're going to do is we're going to add a negative 5 squared, which is 25. Then to balance it out, you subtract 25. Okay, on the y, you divide this number by 2, then you're going to get negative 11. So here, you're going to have to add in negative 11 squared, which is positive 121. Now, if you're going to add in some quantity to balance it out, subtract by the same quantity. Okay, so then what's going to happen? The first 3 terms right here is going to become a perfect square. So here, you're going to have a x something something squared. So what goes in? Do you remember? This number right here. Negative 5 goes in right after x. So then you're going to have a negative 5. And then you're still going to have to drop down the negative 25. And then we're going to do the same thing for the y. So the first 3 terms here is going to produce a perfect squared. So here, oh, don't forget to drop this plus sign. And then here you're going to have y something something whole quantity squared. Okay, so again, what goes in there is this number here. So here you're going to have to write minus 11. And then don't forget the minus 121. And that whole thing is going to equal to negative 155. Okay, so the next step is this. Let's bring all the constants on the right-hand side. So then we get x minus 5 squared. And then plus y minus 11 squared. That's going to equal to negative 155. Now I'm going to add 25 to both sides to make this into a 0. So here you're going to add in plus 25 and do the same thing for that minus 121. Now I'm going to bring that on the right hand side by adding it. So then here you're going to get plus 121. So which gives us, so therefore, what do we got? We got an x minus 5 squared plus y minus 11 squared equals, what is that? Negative 155 plus 25 plus 121. Is that negative 9, I think? Double check my work, please. Okay, so that's that. So what we did was we were given the general form of the equation of the line, and then we made that into a standard form. Now, do you see something weird here? Look at it. This should have been r squared quantity, isn't it? But look at it. We got r squared equals the negative. Could that ever happen in a real number system? No. So in this case, such circle does not exist. And that case, we called it, this is the degenerate case. How did you all do? Hopefully you're kind of getting this. So you know what? Let's do another one. So let's call this one part C. Now we're given 2x squared plus 2y squared minus 32x plus 12y plus 90 equals 0. So do you see a big difference between this example versus part A and B? I hope you noticed that before the coefficient on x squared and y squared, there were 1. But here, the coefficient on x squared and the y squared, they're no longer 1. So in this case, we're going to have to work it just a tiny bit, because in order to complete the squared, the leading coefficient must be 1. Okay, so now if I look at this, there are a couple ways that you can do, but we got lucky on this one. Because look, are all the numbers, aren't they all even, right? Which means that I can divide every single term by 2, including 0. I have to divide the right-hand side by 2 as well. So if I do that, then do you see that the coefficient on x squared and y squared will become 1? Okay, so that's exactly what we're going to do. So here, I'm going to divide this by 2, everybody by 2. And everybody by 2. Okay, so then what do we get? We're going to have x squared plus y squared. And then you're going to have minus 16x plus 6y. And then plus 45 equals 0. Now I think you can go from here. So if you're still struggling with completing the square, pause the video here and try to do it on your own. Okay, but I'm just going to keep going. So here, you're going to have a x squared minus 16x. Leave a little room, and then plus y squared plus 6y. And then leave a little room and toss that 45 on the right-hand side. Okay, so let's go. Let's complete the square. Divide this number by 2, so you're going to have a negative 8 here. Then here you're going to have a negative 8 squared. So you're going to have to add in the 64, and you're going to have to subtract the 64. Now, do you see that this is equivalent? I don't want to confuse you here, but if I subtract 64, right, after I'm adding 64, isn't it same thing like this? If I'm going to add in the 64, I can bring this 64 on the right-hand side by adding 64. So you can easily go from x squared minus 16x plus 64, and then you just add in 64 instead of subtracting it on the left-hand side. But anyways, let me just keep going here. So then you divide this by 2, you're going to have plus 3. So you're going to have plus 3 squares, you're going to have plus 9, and then minus 9. Okay, so again, what's going to happen is that first 3 terms will produce the perfect square. So this up to here. Okay, so what is it going to be? So this is going to be x minus 8 squared, and then don't forget to drop down that minus 64. And then plus, now you do the same thing here. Okay, so then here you're going to get y and then plus 3 squared and then minus 9 equals negative 45. So now let's bring all the constant term on the right-hand side. Then you're going to have x minus 8 squared plus y plus 3 squared equals negative 45 plus 64 and then plus 9. So in this case, what do we get? 28. So you're going to have, therefore, we get x minus 8 squared plus y plus 3 squared equals 28. Okay, so that is actually a circle with the center is at 8 comma negative 3. And be careful with the radius. Radius, remember, r squared equals 28, right? So you have to take the square root of that to get your radius. So the radius is going to be square root of 28. And we're going to have to simplify this. So let's just work this on the side. Let me just change up the color here. Okay, as a side work, let's just break down 28. Side work, SDWK means side work. So 28, so what goes in 28? 2 and 2 times 14. And then this is 2 times 7. So 28 is same thing as 2 squared times 7, which is good because we have a perfect square and we're given the square root, so we can simplify that. So this is going to be square root of 2 squared times 7. So which means that one of the 2 can go outside, right? Remember we practiced this before? So this is same thing as 2 times the square root of 7. Okay, so we got the equation of the circle in standard form. The center is at 8 comma negative 3 and the radius of 2 root 7. So I'm going to stop here. So if you have any questions, please let me know. And if you're still kind of like on the completing the circle, not completing the circle, completing the square, make sure to practice that. Anyways, good job everyone once again, and I will talk to you later.